Alright, I'm going to show you guys how to multiply this and actually graph it by hand. First thing we're going to do, we're just going to multiply. So I'm just going to multiply the first two. Doesn't matter what order you do them in. And you can even save space by just putting a box underneath the first one. And now I'm just going to write negative x and a positive 5. Negative x times x class.
Negative x plus.
Negative x times 3.
Negative 3x.
X times 5.
5.
X times positive 3.
15.
And then within here, after I've multiplied, now I'm going to add or combine like terms. So I have negative x squared. Class that becomes positive 2x. You can still use your calculators, and 15. So I've multiplied this one, and now I'm going to use this one. So multiplying the last one. And you'll notice that this one has 3 terms. It's a trinomial. That's why my rectangle now is 3 units long. And I'm going to put this one blue on the left side. Doesn't matter which order you multiply these. You're going to have 2 and negative 2x. And we're going to do the same thing in multiply. Class 2 times negative x squared. 2 times 2x. 2 times 15. Negative times negative. 2x times x squared. Negative 2x times positive 2x. Negative 2x times 15. Now, this one was not nice to us because if it was written in descending order, x to the second, x to the first, x to the 0, this is written in descending order. This one was not. There's no nice patterns. Look at the nice patterns we get if it's descending. X to the first, x to the 0. Do you see the patterns? It's a little bit easier to actually find like terms. This one's not nice. I'm going to look for the highest degree. Which is the highest degree, class?
2x cubed.
So 2x cubed. I'm going to look for the x squareds. Notice I'm using little check marks. That helps me. Class, what's negative 2 minus 4? So now we're just adding. You just look at the numbers in front. Negative 2 and negative 4. If you don't know that, use your calculator. Now these two have x's. These are like terms. 4 and a negative 30. And then I have that positive 30. Alright. Now I'm going to teach you guys how to graph this by hand. Don't need graphing calculators. Alright, so it's to the power of 3, and I know that I have a maximum of 3 x-intercepts. What I can do is, anytime it crosses an x-axis, or an x-intercept, if I graph one up here, let's just say I make an order pair up here, let's just say I put 2, 0. Notice how my x value is a number, and my y value is 0. Why is that important to us? Is because I can make all of this equal to 0. And it's called the zero product rule. It essentially says if one of these binomials is equal to 0, then all of this is going to turn into 0. Think about that. 2 times 3 times 0. 0 times 2 times 5. 6 times 1 times 7 times 0. What happens? They're all equal to 0, but one of these has to be 0. We don't know which one is 0, so we set all of them equal to 0. X plus 3 equals 0. Negative x plus 5 equals 0. 2 minus 2x equals 0. And all we do from there is just solve. So subtract 3. X is equal to -3. This one you could subtract 5 and then divide it by -1, or I can be smart about it. Just add x to both sides. 5 is equal to x, or x equals 5. This one, same thing. I just want to get x by itself, so I'll add 2x. I have 2 is equal to 2x. Divided by 2, x is equal to 1. Watch what I can do now. I have x equals -3. Label that -3. I have x equals 1 here. 1. And I have x equals 5. Class, is this positive or negative? And what's the highest degree?
3.
So it's cubic. And cubics always start down and up. It's like a linear. X to the first starts down, ends up. So in this graph here, I'm going to start down, ends up. And this has a multiplicity of 1. Class, is 1 odd or even? You'll notice that odds, like x to the first, they shoot through the x-axis. So when I'm drawing this graph, I start down, go through my colored points. Notice how I'm going through those and I don't bounce off of them. So I actually sketched this by hand. Let's now see if this will look like on my graph. Go ahead and have your calculator so you can graph it. So I'm going to use this before I expand it, so x plus 3, negative x plus 5, that's not an x, and then 2 minus 2x. And then I'm also going to verify their equivalent expressions by also inputting my expanded polynomial after we've multiplied. 2 times x cubed minus 6x squared minus 26x plus 30. Press zoom. Standard. That's what the graph looks like. Notice here that I don't need all of these negative x values, so I'm going to change my x minimum to maybe about -3 to about +5. X min, negative. And you can look at the numbers that we actually have right here. -4, highest number is 5, so I'm going to go 6. Y minimum, I'll increase it to -30, +30. These numbers I am thinking about how I can stretch and see the graph. Let me go ahead and count by tens. Let's see the graph. You'll notice that it's going in blue first, and notice how it's coming in red now. And the reason why it's showing over at the same graph is it's basically the same. Now, my graph isn't high enough because I can't see the maximum, and this one down here, class, is called the minimum. So I'm going to have to stretch my graph again. Let's try -50, +50. Comes the red. And that actually looks like our graph, doesn't it? -3, +1, positive 5. Starts down, and then it ends up. Notice if it was a negative value, this would actually flip. So what's new to you is I just graphed this by hand. Eventually, if you come into pre-calculus or later in this packet, I think they're going to actually ask us to graph it by hand.